Hi everyone, Adarsh here from Adarsh Model Train. So today we will see how we can configure light as well as Snap Turnout based on the REST API in our wireless ecosystem. So for that we have to go into our GitHub repo, which will be github.com/adarsh-model-trains. Inside this repo we'll go into repositories where we can see Jmri, Mqtt, Spring Transformer, wireless ecosystem. This repo is private as of now, but once I'm done with the testing, I'll just make it public so that it will be available to everyone for using this code. So once we go into that ESP and Arduino solutions, we have to go into this. And now we have already in the previous section we have seen MQTT snap turnout signal with the light. Now we'll see rest snap turnout with the signals. So once we go into that, we can just download the code here. We'll just download it on our desktop. So connection wise everything will be same as we are doing earlier, like from Uno or Mega we will use RX-TX pin and common ground and 3-volt power supply for powering up ESP, and then we will configure a PC96 board here with SD and SCL line, and we will supply 5-volt external power supply to that, and from the PWM pin whatever our configuration says, based on that we will power up the relay switch, and from relay switch we will use 12-volt external power supply to power up the turnout for throwing and closing, and we'll use a common GND here. And then in this section itself we're gonna use a two PC9685 boards, where one is dedicated for the snap turnout, one is for the light. So we'll see how we can do all this configurations, and once we will do the configuration, our application will itself let us know like how many boards we have to configure and what pin, and what pin we have to use, and what board number of boards we have to use for our experiment. So let's get started for that. So in that next thing, what we will do, we will just use this ESP and Arduino and upload the code whatever we have downloaded here now. So now what we will do, we'll just try to upload the code. We have downloaded the code here already. So let's go into this and let's start the get inside. So once we open the code, here in the code we can see here we need one turnout board, one light board, and total number of boards should be 2, and signal type anode should be false. So this will be our simple configuration. So let's connect the Arduino Uno and upload the code. So we have connected the Uno. Just compile the code, select the board type is good, Arduino, everything is okay. Let's upload the code. So code upload is done. So now in the here we can see total number of boards for turnout and signals are 2, one board for turnout, one board for light, and 2 addresses are configured, index 0 and index 1. So we are good with this. So now next what we have to do is we have to upload the code to ESP. Let's open the ESP and let's connect the ESP here. Let's go into configuration here. Let's see the IP address for this. It's correct. Wi-Fi username password are correct. On this port number, on this URL, our application will expose data, and this is a node ID for this. So let's change the port and let's change the board type. Node MC 1.0. So let's compile the code first. So still it's compiling. Compiling is done. Let's upload the code. So it's uploading the code. So it should be able to connect to the network, but not able to make call. Yeah, it's connected to Wi-Fi. That's correct. But it should not be able to connect to the API server because we have not started yet. So we are good for this as of now. So in the next section, what we will see, we will do all the configurations here. We'll connect ESP with Arduino and then PC96 port and all the configuration, and then we will do the testing based on that. So I have configured everything together, and let's see how the configuration looks like. So here you can see, starting from ESP, this is a 3 volt power supply, and this brown one is a GND which is coming from Arduino Uno. This is RX and TX pin. Black and white is RX TX pin which is coming from Uno. So this is the connection between ESP and Uno, and from PC96 board and from Uno we have taken yellow is a SCL and STA, orange is a STL line which is going from Uno to there, and this red one is 5 volt, and brown is GND which is going to PC96 board, first board. Here you can see there is an external power supply 5 volt which is coming to this breadboard. So from this breadboard we are taking 5 volt external power supply for the first board and second board. So blue one is a GND, white one is a 5 volt and GND which is going to first and second board. So what I did, I have just I bought this connector separately and I just solder it here at the end of that, so that you can snap the PC96 board together. And another thing, if you see, if you have following the video tutorial, I have already explained how we can generate a new address for the PC96 board. Here you can see, here this section is soldered. So this, if we solder these, there are multiple points. If we solder the first one, it will generate the address number 41 for us. So by default this address will be 40, this is a 41. So this is how we have configured the board, and then rest is same how we have configured the snap turnout earlier, like from the board number 1, 0 and 1 which is coming, it's based on the address which our application will tell us. Based on that, so it has told board number 0, pin number 0 and 1 going to snap turnout, for snap turnout relay switch. And so these two are the signals from PC96 board for snap turnout. And here you can see, from the end of the board I have taken 5 volt and GND which is coming to this breadboard, and from that I have used the same 5 volt and GND from this breadboard to power up this relay switch. And here you can see there is an external 12 volt power supply which is coming from here to this breadboard, and from this breadboard these two wires which are taking it to the central location of the relay switch, and this orange and yellow, this is taking it back to the breadboard here. And if you see here, if you see clearly, so this uh, black and green wire which is connected to this yellow one, and orange and blue wire which is connected to this orange wire here for this side and this side, and this red one is a GND which is taking GND line from the breadboard here directly. So this is how we have configured the relay switch. And now we relay switch and the snap turnout. And if you see here, from the next board, from pin number 0, we have taken a PWM pin and passing it to our second relay switch to control the light. And if you see this, or this yellow and blue wire, yellow and orange and blue wire which is going to this single relay switch here, with to control this single relay switch. And if you see here, white one, this white cable and this black cable. So this black cable is taking power from this breadboard and taking it to the center of the relay switch, and this black one, if relay switch is on, this black one will take and this white one will take and power it this button, this LED. So this LED is the short leg is towards the GND of the breadboard line, and the long leg is towards this resistor, and this resistor is connected to this white cable which is taking up the power from the relay switch. So if relay switch is on, this one will be active, and if it's off, this one will be active. So like that we have configured each and everything. So now what we're gonna do is we're gonna test everything together, so one by one, and then we'll take it from there. So what we will do, we'll start the MQTT and our application first. CD desktop config python start. So our MQTT has been started, and let's start our application. Also cd spring. So command what we want to get it, that command is here in the transformer app. So let's here in spring transformer app. So this is a command which we have to execute. So here I have mentioned in all other tutorial that we can download jar and configuration file, which we already have everything here in this folder. So before starting that, let's verify the configuration what we need, that is there or not. So for node 1 is enabled, publishing is enabled, means it will publish data to MQTT. Enable REST API, this is what we need. So enable REST API is true. Light count 1, 2 LED signal, 3 LED signal count is 0. We need 1 snap turnout, servo turnout is 0. Total turnout board should be 1, and total light board should be 1. So we are good with our configuration. So let's start the application and change the network. So now we are in our network here. So here we can see our application has connected to MQTT. So the next step what we have to do is, here are on the right network. Next step what we have to do is we have to open the panel pro. Panel Pro is open, but before that we will trace out the data which is published. So this is the data which will published by Jmri. We need 2 shells. So one is this, and another one what we need is what our application is pushing. If we want to see what is errors are getting, we can listen to this one also. So let's minimize this here. initial here, and let's open the tool table turnout. Here you can see snap turnout thing. So just see the network is correct, everything is correct. So here we should because ESP is not connecting to this, so we will not see anything here. So now we'll start pressing the button. So before that, what we need to do is we have to just verify our configuration. So to verify our configuration, what we have to do is, for node 1 we have to verify the configuration. So we'll just copy this. So node 1 is enabled, publishing is true, REST API is enabled, light count we want 1, signal 2 LED, 3 LED signal count is 0, servo turnout count is 0, 1 snap turnout, total turnout board is 1, light board is 1, total light pin we need 1, and total snap turnout pin we need 2. So total number of servo turnout board is required 0, total number of snap turnout board is required 1, total number of light and signal board is 1. So for snap turnout, Jmri 50001, board number 1, board number, pin number, status. So board number 0, pin number 0, status throw, board number 0, pin number 1, close. Light 10001, board number 1, pin number 0, on, board number 1, pin number 0, off. So if we just verify our configuration here, there are two board number 0, board number 1, board number 0, pin number 0 and pin number 1 here for snap turnout. Board number 1, pin number 0 is for LED, light basically. Here LED representing the light, not the signal. So now you can see here LED, the LED which represent the light here. So now we'll test the light first. You can see here it's getting on and it's getting off based on the control from the Jmri. And now we'll test our turnout. So here you can see it's getting throw and it's getting close. So it's simple configurations. You can see what Jmri is pushing and what our application is transforming here now. So I guess you can see the closer look here. Turnout is throwing and closing, as well as the light which is getting on and off. So the train can go straight and train can go to the turnout position. So I guess that's it for this tutorial. In the next tutorial we will configure signal, lights and turnout together, and then we will do the testing. So that's it for now. If you like this content, please subscribe to my channel and stay tuned for upcoming content. Thank you.